So what about cosine theta? Okay, so cosine theta equals 0.5. That tells me that cosine goes with the x coordinate. So the 0.5 should give me 0.5, or I'm going to use a fraction value of 0.5. This should be negative 0.5. So negative 0.5 to 1 or negative 1 to 2 ratio. Okay, so there's my ratio. Should be negative 0.5 here. Okay, rewrite that. So it's going to be negative 0.5. And we have this angle here. This happens to be a special triangle. Okay, but even if we put it into our calculator, okay, and again, I want you to try this on your calculator. Make sure your calculator is working. And I want you to appreciate that your calculator actually understands standard positioning. So when I give the calculator negative 0.5 as a ratio, okay, so this is what I typed into my calculator. I did the inverse cosine. So my input is my ratio, my output is my angle. Okay, so it's not 30 degrees, it's going to be 120 degrees. Okay, so that's what my calculator gives me. So what your calculator understands is it knows that you're telling it standard positioning. You're telling it it's 0.5 to the left, which relates to quadrant 2, which relates to the angle 120 degrees and not a quadrant 1 angle. Okay, so it understands this. So there it is, 120 degrees. And that looks exactly like the right place. But the problem is, remember that cosine relates to x? And in this case, our y is positive, but who's to say that our y wasn't negative? And we have the same positioning down here based on that ratio. The 0.5 is negative 1 to 2 ratio along the horizontal. This green position also is the right position to give me that cosine ratio. Okay, and I need to figure out what that angle is, and we're going to call this angle theta 2. Okay, now there's a few ways you could do this. You could work out this reference angle as 60 degrees, and we know that this is 180 here, so another 60 would be 240, and that would give us the correct positioning. Okay, and you could do it all sorts of different ways using the symmetry of those two triangles. However, we're going to do it this way. So we know that the theta 1 from our calculator goes in this direction from 0 to here. Now notice that we could also go the same distance in the negative. So instead of going positive 120 degrees, I'm going to go backwards 120 degrees and get to that same position. That angle is 240 degrees. So I'm just going to write that down first. So theta 2 is equal to 360 degrees minus 120 degrees, which is 240 degrees. And that is a correct position for that theta 2 angle. So that theta 2 angle actually has this formula. And this formula, you can memorize this formula if you like for cosine. It's a different one for sine. But really what's more important is if you understand that cosine is x and it has folding symmetry down this way, that means that the top half and bottom half has to match. So we know that this angle here from 0 is the same angle backwards from 360, or 360 minus theta 1. And so that's how we end up with that formula. So the position that we have from our calculator, which we call theta 1, is 120 degrees. Theta 2 is going to be 240 degrees. These are two different locations, so these are not coterminal angles. They are unique solutions, two unique solutions to that one cos ratio. So looking at this one here, we're asked to solve for the angle where tan is 2. Well, tan being 2 means the slope is 2. So here's my line with slope of 2. So there it is. I've got a ratio of 2 to 1. And I've got my angle theta here. In fact, I can even solve for that angle. This is not a special value, so I need to actually for sure type it into my calculator. So the ratio is 2. and I'm looking for the angle. When I type that into my calculator, I get second tan of 2, and that gives me 63.43 degrees. So 63.43 degrees. And looking at that picture with the slope of 1, the slope of 2, that looks about right. So that's the correct position. That angle that gives me this red dot is the right position. But if I look at this circle more carefully, well, that slope passes through another point over here. And that definitely has a ratio of -2 divided by -1. Rise over run is definitely +2. So in fact, there's another angle involved here that has the same ratio or slope as 63.43 degrees. Okay, and we need to use some symmetry here to find that θ2. So this is my θ1. I'm going to write that as θ1. So θ1 comes from my calculator. θ2, I have to use a symmetry. Now this is not folding symmetry. This one has rotational symmetry. So if I go to the other side of the circle, which is how I will get the other point through that slope, if I go to the other side of the circle, that's going to be the same as adding or subtracting 180 degrees. So if I want to find θ2 in this case, θ2, I'm going to start at my 63.43 degrees, and I'm going to go to the other side of the circle. So I'm going to add 180. This is where this formula comes from. So θ2 position then works out to be 243.43 degrees. Sorry, 243.43 degrees. Okay, so that angle is 243.43 degrees. The standard positioning is that, and I found that by getting my calculator to calculate θ1 and going to the opposite side of the circle. Once I have that symmetry, once I understand that slope symmetry, that's where I'm going to find my θ2.